Hi everyone, thank you for joining us today. I'm Minakshi, I'm your host for today's session. Today is our fourth session of this Open Buildings Designer live series. Accompanying our sessions, we do have a free 21-day trial of the software so that the users get a chance to try out what we show in our demos. If you're joining us for the first time here, let me introduce Open Buildings Designer. It's Bentley's Building Information Modeling or BIM tool for the different disciplines that go into a building: architectural, structural, MEP. We also refer to it as OBD. You can download your free trial by scanning the QR code in the top right corner of the window. There will be tips and tricks, user case studies along with it to ensure you gain the most during this trial period. So that's me. I'm a product consultant for Open Buildings Designer. I'm based out of Singapore and we have worked in the AEC industry for more than a decade. Joining me is our main presenter, Alan Sujai. That's Alan there. And our backup presenter for today, Kashia. Alan is a consultant with Bentley Systems. She's based out of Singapore and specializes in open buildings designer, working on a multitude of cross disciplinary projects and supporting our users. Kasia is based out of Poland. She's an architect with international experience in design. Joining Bentley as a building application engineer, she focuses on functionalities of open buildings design as well, and she provides support and trainings to the users. Kasia will also be able to help us answer some of the questions or comments posted over LinkedIn today. So please go ahead, put in your questions, if any, in the comments section. And here are our email IDs. Feel free to email us and ask your questions or share more about your current BIM projects with us and what are your current challenges. We'd love to hear from you. You see a QR code on the top right corner of the window. In case you have trouble scanning the smaller one, here's a larger version of it. Scan to download your free trial. Like I mentioned, you will also receive tips and tricks and user case studies in your inbox to be able to get started and use the software most efficiently in those 21 days of the trial. If you're viewing this session over LinkedIn Live, do know that the resolution depends on the bandwidth and quality of our internet connections. So do close down any applications that use too much of the bandwidth. Just in case you don't have a good internet connection, the recording will be posted on our YouTube channel. Our previous three sessions are available on the Open Buildings Designer YouTube channel. We have the link right here, and Kashia will also paste the link in the comments section. Our previous three sessions are available on the Open Buildings Designer channel, and we demonstrated creating a BIM model of a building from scratch, introduced the basics of object-based modeling tools, extracting schedules, etc. So do look at the YouTube channel, subscribe to it. That is what we are hoping to cover today. Alan will briefly touch on the capabilities of Open Buildings Designer that make it the right tool to transition from 2D space plans to 3D form exploration with parameters and computational design, to adding more information in your model, creating reports, and setting up the views for design documentation. So Open Buildings Designer is actually built on top of the MicroStation platform, that is Bentley's CAD platform for 2D and 3D design and drafting, not just for architecture, but for almost all industries. Hence, OBD includes all the functionalities of MicroStation with its own added BIM capabilities and even a computational design companion app. So instead of switching platforms for drafting, then doing your BIM modeling in another software, etc., OBD allows everything that you need in one single platform. This streamlines the effort, saves time, and brings more accuracy to the models at every stage of design. Alan is being a little ambitious. We have a lot of topics to cover today in 50 minutes, and hopefully we will have time to take some questions. So if you have any questions, again, please do type them in the comments section. We will be answering them either right away or take them at the end of the session. So I'm going to hand over to Alan. Alan, so how
Hi.
early on in the design process can we digitize our design in Open Buildings Designer? Can we take our, let's say, our napkin sketches in and work on the project brief with just the areas and adjacency diagrams, etc.? Is it something we can do in Open Buildings Designer?
Yes, that's definitely possible in OpenBuildings Designer. So if let's say that you just have a sketch that you drawn out on your
Do you want
paper,
me to
uh,
share your screen?
oh yes, you can do so right now. Yeah,
Mhm. Okay, great.
yes. Let's say that you have some 2D plans from a different software. So if those file formats is applicable or something that we can bring into OpenBuildings Designer, you can definitely reference it in and use it as a basis for your modeling. So in this case, let me maximize this view. Okay, we have this sketch for this marketplace, right? So this is a 2D plan from a software, a 2D software, and this is just a sketch on the area that is allocated for each space. So what we can do is that we can use the built-in space tool in Open Buildings, right? We can use this to quantify and get data such as your area as well as your volume, and we can use this to our advantage. So let's say that we choose something simple, maybe let's just a general, okay? So let me bring this up. So let's say that we want to quantify or get the area of these dry goods. So let us change the name to dry goods. We'll be placing by rectangle. So what we have to do is to just trace over this dry goods area to get the area, which is 24 square meters. So you can do the same with another area, let's say produce, and we can draw the shape from this area, right? So you can change this to wireframe to see, okay, this looks like a good rough estimate. Right? And what we can do is that now that we have the space, we can quantify it. So let's go to our schedules and okay, you can see that we have two general spaces labeled dry goods and produce. So what we want to recommend is that we want you to use whatever you have on hand first to make use of your for you to create your models. Right? So this is the perimeter, this is the area. Right? It's looking good. So what if you want to go one step further and to create your walls out of these spaces? Right? So what we can also do in open buildings is to go under walls and we can place our wall using this space. Let's choose maybe new default interior wall. Okay, what we can do is to select from space. Let us create one within our space tool. Go back. Now we have our wall created based on our dry goods. So this is all again from sketches, making use of what we have. So let us go back to schedules and you notice that right, you can quantify it. So we have four interior walls right here. We have the width, we have the height, and we can change directly in our schedule. Okay, 3000. So we can do the same for this other part of the wall. From space, we can create a produce area. Right. So this is how easy it is for you to bring in what you have, in this case, a sketch for you to create your plans. Mhm. Okay. So
And
what
how
else?
how can we just quickly select these elements if we need to just
Mm. So what we can do is that we can make use of our element selection, okay, to select either all of the goods or all of the walls, or we can select individual walls that we only want to modify. In this case, let's say we only want to modify 1, 2, 3, 4 these walls. We can use the element selection, okay, to add, subtract, invert, or clear all of our selection. From here, we can go to modify properties and we can change the dimensions accordingly. So this is 4000. So this makes it easier for us to modify what we have, what we selected, so that we select only the ones that we need.
right?
Mhm.
Okay. So that's a easy way of just going about your spatial planning. And how about adding some constraints and parameters? Could you do that to in very simple terms? Could you just explain that?
Yes, sure. So let us create a new file or let's open one that I've prepared. So why we have constraints, right, is so that we're able to modify our components or our objects easily using the variables and so that all of the elements are parametric. So when we talk about design freedom, we're thinking about how parametric or how easy it is for us to modify or adjust according to our project needs. So in this case, let us look at these two shapes, okay? This is based on our basic MicroStation tools, okay? The reason why we're able to do that is because MicroStation is built into Open Buildings. So if you look at the top right corner, or top left corner, sorry about that, we have these workflows. Okay, workflows are just an easy way for us to categorize our tools. In this case, the first tool workflow is our BIM workflows. What I mean by that is that building design is for architectural, structural, and whatever tool that is linked to your architectural and structural needs. So if you look at building design, okay, this is where you have your mechanical, plumbing, electrical, your scheduling, and everything that has to do with your MEP. Right? And if you look at the other portions, we have drawing, general, and modeling, which are our MicroStation based tools. Okay, so this doesn't mean that if you're working on your open buildings project, you have to go to MicroStation to do your modeling. You can actually use in the built-in MicroStation tools to create your basic CAD models. So in this case, I have this simple block, okay, made using this placement. Okay, using the built-in MicroStation tools again, we use our constraints to apply, okay, some dimensional and geometrical constraint. So in this case, geometrical constraints are when it comes to parallel, perpendicular, coincident, and such. So if we look at this block right here, how we apply constraint is to either select what we have here, maybe perpendicular. Okay, we select the sides that are applied. We can think, okay, if I know this is a block and I know that these two sides are parallel, we can make these two sides as parallel, which means that if we adjust it, okay, it's still parallel, okay, it's still parallel. Right? So we can even go one step further and use this auto constraint that has been built in. So how we use it is to select it and select our shape. So they actually ask you whether this is sufficient, or if you think there's something better that it can do, you can either accept or reject. In this case, I will accept it. Right, so now it has applied the parallel constraint to the other side. Right, so we can see when we hover over the icon, it shows what are the sides or the points that have been applied to. So let us check the degree of freedom. So the degree of freedom of how flexible or freely your shape can move. So for example, if you want to model an arm, okay, you want your arm to move forward, but then you didn't apply constraint, so it moves to the side. So if you want it to move forward, you have to apply a constraint so that it moves forward. Okay, so let us see. We have a degree of freedom of 5. Okay, we can add we can add a dimensional constraint. So this dimensional constraint deals with values. In this case, it says that this value right here is 1500. Okay, we can accept it. Right, we can do the same for the right hand side. So if we want to modify it, we can edit dimension and set it to a different value, let's say 1000. Okay, if you notice, it's parametric, it moves accordingly. Same goes for the width. Let us set it to 1000. Notice that it's moving accordingly. Let us check the degree of freedom again. It says that there is a degree of freedom of 3. Right? So what we can do is add more constraints so that the degree of freedom is 0. So in this case, let us set it as fixed at this point so that whatever value that has been changed, it would not move uh, at this point. It will move away from this point. So let us edit this value to, let's say, 1500. Okay, notice that it moved further away. If you edit this value to 2000, let's check it again. One more. Okay. So let's set a fixed value or fixed constraint to the side so that it either moves left and right. Okay, let me go back. Okay. Notice that there is this degree of freedom, how it's still quite flexible. We can apply the fixed constraint to this side so that it will not move about. So now this is fully constrained. We can go one step further and apply a variable. Okay. Variables are, if you use generative components, variables are how you can modify or change your values based on these variables, okay, these parameters. So let us see. Okay, I have this block I want to modify by the length and the width. So the length as well as the width. Okay, so let's see. Maybe for the width, I want this to be 500. Okay, and for the length, instead of typing it out, I want it to be an expression, an equation. So we can go under expression and set it so that the width, the length is the width times 3. Can test? Okay, it's valid. Let's see. Okay, it has already calculated for us what is this length value. So let us apply it again. So change this dimension to width. Okay, change this to length. So after we test it out, or after we've edited our dimensions, we have to make sure that it works. So we have to go to our width and change to maybe 1000. It looks great. It's moving correctly. So width is 1000. Length should be 3 times of the width, which is 3000. So 1000, 3000. Okay. So this is how simple your 2D constraints or 2D element can be constrained. So if you want to go one step further and apply to something with an angle or a radius, what we can do is to apply the same method or to constrain. Okay, it says whether you want to accept or reject. I think it looks great. I'll just go left click. Okay, show degree of freedom. That's degree of freedom of 6, which means that this shape can still be easily modified. Okay, the reason why we're constraining our components or our elements is so that we maintain the design integrity. You want your table, okay, you want a table to still look like a table after you apply your constraints. So that is why we add some constraints so that it still looks like a table. Yeah. So let's see. Again, fix on the point, fix on the length. Let's see. Okay. Now we can also use the same variables that we use for our initial model. Okay, this bottom would be the length. Okay, since it's ready, you can just use it. On the side, we can be using the width. Okay, so it looks nice. Okay, so make sure that we test it out first. Okay, it's important for us to test to see that it actually works. So let's change it to 500. Okay, it's correct. 500, 500 times 3. Okay, but what about this arc right here? I want to be able to adjust it. I want it to also be parametric. Okay, remember you have the option to make it parametric or not. Um, you can leave this as a fixed value. Don't add any variables to it. But if you want to do so, you definitely can. So let us use by element, select this radius. Okay, it says that it's using the radius of 250 millimeters. Let's use this for now. We can add one more variable called radius. And with this radius, what we can do is that again, you can either type in your own values or you can use an expression. So let us see, let's see, maybe 300. Okay, let us edit our dimensions to 300. Or again, you can use expression Let's see, maybe it's the width minus 50. Valid. Okay, it will adjust accordingly. So you know that the variables and the constraints are working, that when you modify or change the value, it still looks the same. So this looks great, this looks great. Right. So you definitely can still add, okay, in this case you don't, but you still have to check whether your degree of freedom is 0 to make sure that it's fully constrained and it's maintaining the design integrity. So again, either degree of freedom or moving the points. So that is how it is for your 2D CAD constraints. Okay, it's still relatively simple because you have only a single plane, but when it comes to a 3D component, it is different. Mhm.
Okay. Okay. The common perception is that BIM software is best at doing like very regular geometry. But can you
Mhm.
show us like the blue tunnel like form that we had on the cover slide? How do you do that? The one with the ribs, and
Oh,
how can we do the same stuff to it? Can we add like the constraints to it and keep editing it with those constraints?
yeah, we can definitely do so. So let us open up a new file. Okay, all right. So in this new file, what we have is okay, this is the end product. Okay, so this is our blue tunnel that we have in our cover page. So it has the ribs as well as the shell. Okay, and all of this is constrained, which means that if you modify or if you adjust it, okay, it will modify and it will be parametric. So let us go through how do you create this. Okay, so again, this is using the simple microstation tools that we have built in. So using the common tools, what you will first do is to place a line as well as an arc. Okay, so this is through start and mid. Yep. Okay, so this is what our tunnel will look like at the start. Let me move it a little bit away. Okay, so right now you can notice that if you use or if you move your arc or if you move your line, okay, these are still working as two separate entities. So what we can do is to apply a geometrical constraint, okay, so that whenever you move your arc, the lines follow and vice versa. So in this case, we use a coincident constraint, which is how these two elements can share a single position or single point. So in this case, the bottom of the arc as well as the end of this line. Okay, let us test it out. Okay, notice that it's moving together. To do the same for the other end. All right, right. So it's looking great. It's constrained. Okay, whenever I move the line or the arc, it moves accordingly. So that is what we want. Okay, let us add our profile for our ribs. So that is using a simple smart line, right? And how to make it parametric is again your variables. So under constraint variables, okay, I've prepared some variables right here. So in this case, we have the arc thickness that we'll be looking into, right? So this arc thickness, I've set it to be a value of 2500. We can apply a by element dimensional constraint, 2500, which is the arc thickness. Okay, so I'll move it closer. And what we can do is we can use a coincident constraint and make sure that when I move my arc or my line, okay, the line should move as well. So that is for our profile, for our 2D portion. Now we want it to be 3D. Okay, we want us to be able to see it in a extruded element. So how we do it is to go under solids, okay, and extrude along so that this arc thickness can follow this arc. All right, so let us expand this out. Okay, so what we can do is to set a center. Okay, thickness would be the depth. Okay, and we want to show the path. So how we apply this is to select the path followed by this arc thickness. Okay, so if I go back one step, okay, if you look at arc depth, this is the thickness, which means that since we use okay thickness of center, it will be 2500 millimeters away from this point. Okay, so let me apply it again. So this right here is 5000. Okay, this is 2000. You notice that since it's extruding along this path or this arc, you can left click and it would apply accordingly. Mhm. Okay. Remember to check the variables are working by changing its value. So maybe 3000. Yep, it's working correctly. 10,000 correctly. The same with the thickness. Let us check for 5000. Okay, it's working great. Okay, so now we have one rib. Okay, in our cover image, we have 1, 2, 3, 4, 5. What we have to do is to create copies of it. Let us select the entire thing, go under copies and create 4 more copies. So in total, what we will have is 5 copies. So I will left click to accept. Okay, we've selected the entire thing. So all of these are constrained and all of these are using the same profile with the same variables. Okay. Oh, let us go one step back. Okay. Before that, let us change this so that we're able to differentiate between our ribs and our shell. So let's go to the level and change it to ribs. Okay. And the color will be by element, which is in black gray. So our first one is done. Let us repeat the steps. Okay, we'll copy over, create 4 copies, and we will okay, 1, 2, 3, 4, 5. Okay, so it's looking nice. Right. So what we're left with is to place our loft or the shell of our tunnel. So let us go to surfaces and loft. Yeah. To select all of this, we have to make sure that we drag and yep, select all of our profile. Okay, so this path right here. So this is why I set it as show path so that we can select that. So left click to accept. Mm. So this is looking great. Make sure to change this to the correct level. In this case, it would be shell. Okay. So now the shell is blue. The ribs is in black. If you want to test the variables again, let's try that out. Thickness, maybe it's 5000. Okay. That can be 6000. Okay. So it works well. So what we can do is that since it's parametric and we've applied our constraint, when we move our okay, we move our points, it should still okay, be moved as well. So not only the line, if you want to change the arc, you can also do so. So let's go to the profile. We can change this arc. Okay, and this is how easy it is to create a simple model, okay, using our built-in microprecision tools. Okay, one more step. Okay, this is still a loft. It's still flat. So what we can do is to go under solid and thicken it to, let's say, 500. So now this has thickness to it. Okay. So if you want to hide this, you can go under your view attributes and you can turn off your markers, which includes your constraint. Yes. So that's how you do it for your 3D constraints. Mhm.
Okay, that's cool. And can you apply the same method to like the AEC elements present in your building design mode,
Oh
like
yeah,
a wall or a? Okay.
yes, so we can do that. So as you can see, this is just a simple CAD model. If you look at the properties, it's just extrusion, just a solid. So what we can do is that we can open up the next file, okay, where we can create a wall using the same method. Okay, yes. So again, if you want to create a beam element or you want to place a beam element, it's under either building design or building system design. So if you want to place a wall, it's under building design architectural wall. Okay, let's go on a place wall. Let us select a specific, let's see. Let's just use this new default exterior wall. Okay, something simple to place by line, and we will place our wall. Okay, so again, I'll go back to the wall. You notice that we have so many tons of different types of wall that you can place. Okay, right here, this is a different wall. Okay, and if you want to modify it, okay, you can still select the element and you still modify it. So in this case, if you hover over this wall, you know that it's a beam element, okay, because it says a wall. It will show you what type of wall. In this case, a new default exterior wall. There's a width, a height, as well as a part family definition. So from here, we can go back to our modeling workflow, okay, and we can bring in a more flexible or more parametric wall. Okay, in this case, we're using a surface, okay, and we can construct surface. Okay, so what we have to do is to place our data point to this end of the wall. Okay, use this point as our origin so that it's of the same height. Okay, now that we have this, just left click, okay, and we have our surface. So let's go to properties. Okay, it's a B-spline surface. So to make it more like a wall, we do need to have some thickness. It can't be just one single line. So let's go to solids, thicken, and we'll set it to the same value, which is 150. Okay, depending on where your surface is located, it will either be forward or backwards. In this case, it will be backwards. Okay, you can see. Oh, so this is 2000. You can still go back, edit feature, and set it to 200. Yeah, so it's 200 for our actual wall and 200 for okay, our surface. So let's say that we want this to be, you want this point to move forward or you want it to be of a different okay, shape. What we can do is that we can modify by selecting our B-spline surface, and we can bring it forward, adjust the points as per necessary. Okay, so we can go one step further and even quantify it. Right, so because right now it's still a simple, okay, solid. We can go back to our BIM workflow, okay, our building design workflow. We can go under data reporting, add data. So what we're doing right here is to add some BIM properties and to make it somewhat like a BIM element so that we can use it for our models, we can use it for quantification and such. Okay, let us scroll down and we will look for wall. Okay, so we can either pick the same type of wall or something different. Let us go and choose our okay, default exterior wall. Once we see this, we can either add the properties just like a simple beam element, or we can apply to this solid. Okay, let us select the solid now, or select this wall now. Okay, so now what we do when we see the properties is that we can see that it's a wall, new exterior wall. Okay, by definition is also wall exterior, and we can have some quantification as well. Okay, so it looks and acts like a beam element. Okay, the only difference is that what we can do is we can go to the points and we can adjust accordingly. Mm, right, that's what you get when you create your own flexible um, wall using our surface tool. Mm,
Okay, that's quite cool. So that's the major advantage of having microstation features inside the BIM tool.
mhm.
So so similarly, can you just show us how to add intelligent data in, let's say, just the simple 2D layouts and 2D models?
Oh, yeah, sure. So what we did is that we added to a 3D element. We can do the same for a 2D model as well. So let us go to another file. Okay. So what we have in this file is a 2D plan. I've added some example um, furniture. Okay. And what we can do is that we can add data to it. Okay. So if we were to select this element, okay, look at the properties, it will just say that it's a cell. It's a cell chair. It is a cell table. Okay. So if you want to look at the properties, it really is really simple, just a CAD model. Okay. So this is okay. This can be done using your basic microstation tools, your basic CAD tools, right? But then if you want to quantify it, what OpenBuilding has is that you can also do the same method by adding instance data. So let us go to the same building design. Okay, add data. Okay, let us go to add instance data. So instead of the wall that we used previously, we can go to, okay, we can look for furniture. Do-do-do. Okay, furniture. Right, so these are the existing catalogs or objects that we have in Open Buildings. So we can use the same naming, the same properties of these elements. So if you want to make your own custom catalog, if it's own custom properties, you can still do it first. Then you can use the same method to apply to your 2D elements. So in this case, let's use chair club upholster. Okay, we can left click to apply to this. Okay, so let us look at the properties now. Okay, we have some beam properties. So this is the manual way of doing it. If you look at the schedules, you still can quantify it. No issue. But what we can do is that instead of doing it one by one, okay, since we have quite a number of it right here, What we can do is to use our element selection, okay, and select by attributes. Okay, select by attributes. Okay, settings would be a cell, and we'll select or type in our cell name. So remember, we have our chair cell and our table cell. We can go to our okay, this portion and type in chair. Okay, all you have to do is to type in, close this. Okay, it's in the master, apply. So what it does is that it select every cell that is the chair cell. Okay, notice it didn't select the table. What we can do is to go to our add data, and using the same method, left click anywhere in your view, and what happens is that when we go to our schedules, furniture, okay, it shows that it has all been applied. So it says that there are 24 items. Okay, what we have is 24 chairs. Okay, we can repeat the same for the table. Let me just clear the selection. So table. Okay, so if you typed it wrongly and you apply, it will show that it's not there. So what you can do is that you have to make sure that it's the correct naming. Okay, apply. Yep, you can see that it has been selected. So now this is ready. What we can do is we can go to add data, and we can look for furniture table. Table. Okay, table. Okay, again, if you want to add data to it, you can go ahead and do so, or you can add it after you've placed it. So this has been placed. Let me put it back. I would clear this selection. Yep, no worries. We go to our schedules. Notice that under furniture, you should have both your chair and your table. Okay, chair and your table. Right, and if you want to add data to it, you can definitely do so. Okay, let's say I want to add data for all of my table. I can go to the type ID and set it as T01. We can do the same for our chairs, C01. So you can either edit it in the schedule, or you have the freedom to use Excel if you prefer. Definitely. So that was explained in the previous webinar on how you can customize your reports. Okay, so we go back and we check our properties. Okay, we're able to see that it has been applied. Yeah, so that's how you do it for your simple 2D CAD models.
Okay, great. How about can you show us how to access these the BIM properties in models in the Open Building Designer? How do you look through these?
Oh yeah, sure. So what we have so far that we shown is just simple microstation tools plus some BIM elements. But you still have to remember that Open Buildings is still a BIM software. So if you want to create BIM components or place or do any BIM modeling, okay, you have the capability to do it directly in Open Buildings as well, definitely. Okay, for example, what we have right here is okay, a model. If you select the components, it will say that it's a slab or if it's a wall. Okay. If you look at its properties, okay, it will even say that it's a wall, a slab, and it will give you more details, make it more intelligent. Okay. Okay, while it's loading. Okay, I'll use the same file right here. Okay, so for example, if you want to work on your architectural model, you go to wall and you can place a basic wall. Okay, so if you look at the properties, it will say that it's a linear form, a wall, and depending on what I place, it will be either concrete wall, a retaining wall, and such. So same goes if you want to place a structural model. Okay, let us place a steel column. Okay, so even though it's in a different tool, you can still place it in the same file, no worries. Okay, just a second. Okay, and we can do the same if it's a mechanical, electrical, and plumbing tool. Oh, yeah, because this is beam elements, these are intelligent. If you want it to be parametric, you can definitely do so in open buildings. Mm-hmm. Right, so place column. So you have your intelligent data right here. Okay, your structural data, the mark. Okay, your construction phases, fire rating. Okay, let's go to building system design, mechanical. You can also place a duct, either a supply, exhaust, a return ducting, definitely. Okay, and with this data, okay, remember these are beam components, so you're able to see beam properties. Mhm.
Oh, that's great.
Yeah.
Okay. I also see on your agenda that you will be talking about computational design, even though we had the last session with Jinling. So, do you want to just quickly introduce our audience today to computational design?
Yes, sure. Let me share this. Okay, give me a second. Okay, so this is just briefly on how okay, you can use computation design for your design freedom because it's still a parametric software, okay, meaning that if you want to create your building, you can either do it in the basic open buildings or you can use open buildings generative components to create your building. And instead of using the constraints or the tools that we have, what you can do is to okay, make use of your nodes, okay, your points, your lines, your solids, okay, bring it over to a graph, okay, where you join the two nodes or the nodes together, and you can modify everything through your controls. So this is similar to what you see when you create your components. So you can either do it in um, okay, either platforms, okay, because both is still open buildings. If you want to open your basic open buildings model into generative components and add some computational design, you can still do so. Definitely, it's the same software. Um, it's just that it's depending on your preference, definitely. Instead of using variables, they have controls right here at the bottom, which allows you to use sliders or change the values, okay, separately. Yeah. So again, it's totally depending on your preference. Um, right here, we even have a building where you can use generative components to manipulate the height floors, the number of floors, and all that. Okay? And again, it's it's a wonderful, wonderful tool that you can use if you would like to try out. So we had a webinar, the last webinar on it. If you're interested, you can definitely go check it out. Yeah.
Sure. I think we have the link in the comments section, so do check it out. And okay. And lastly, I think you were going to show what are dynamic views and how can you set up your design documentation.
Yes. So we'll go back to this model that we have right here, this composition model. Okay, so in open buildings, what we encourage and what we promote is that it's all dynamic models, which means that your 3D model, your drawing, and your sheet models are all linked. Okay, which means that again, that when you create your plan, okay, whatever changes to your 3D model will also be seen in your sheet model, which has your annotations and your dimension, as well as your drawing model. So everything is all linked together. So let us look at this file. Okay, so I prepared a model that we can refer to. Okay, so that was the 3D model that I've just showed. what I did was that I created a plan, okay, based on that 3D model. Okay, so this is the plan that was used. Okay, we can go back to our 3D model or our our sheet. Let's see. Yep, this one right here, the bottom. And these are all linked because these are references. Okay, let me pop this up to one side. Okay, so these are references, which means that if I were to open this up in a separate file, okay, let me open in new session, the actual architectural file. Whatever changes in a 3D model will be reflected in our drawing and sheet model just by refreshing it. Okay, so what it allows is that one colleague or one user can be working on a 3D model, the next can be working on your drawing, placing annotations, placing dimensions, and the third user can be tidying up your sheet model. Right? And all of these can be modified or updated just by refreshing the reference. So what we have is, okay, this is the initial file. Okay, a grocery. Let's say that after some planning or some decision making, we do not need this wall. I've removed it. Okay, what we can do is that I'll just move it one side. In this file, I can just refresh it. Give me a second. Okay, I'll deactivate this. Okay, and I will refresh the model. Okay, remember we had a wall right here. After I refresh the model, okay, it would reflect that it has been modified. Okay, see? So we can try it out again. Okay, we can try it out again. So, oh, maybe I want it back. So I'll just undo it. Okay, I move it one side and I can refresh this reference. Okay. So depending on how big your model, it's gonna take a little bit longer. But notice, okay, since it's all dynamic, it's using hypermodeling, whatever changes can be easily reflected in your drawing as well as your sheet model. Yes. Okay. So that is how this hypermodeling, how these dynamic views will help you with your modeling because it helps to improve your productivity since other users or other people can be working on the same model but different portions. So the 3D, your drawing, and your sheet model. Yeah.
Yeah. Do you have anything else you want to add, Alan? We have 5 more minutes to go.
If there's any questions, yeah, we can go ahead with
Okay, we
that.
don't have any questions, but I'll just introduce some of our content to the audience. So let me switch to my screen. There you go. Okay, so I'd like to direct everyone to some more high quality learning content for OBD. We do have webinars, so that's the link. Do visit our webinar page to look for some focused subject webinars, like we had one for station design and one for water reclamation plants. So we've had for civil engineering as well. So do look at that. And we have a YouTube channel. The link is already posted in the comment section. Kasia already posted it. So look through that, subscribe to it, and we do post a lot of high quality content every now and then. And it's not just for architects, even for MEP engineers. We do post videos and self learning tutorials. So take a look at that. And we don't have any questions for today as such. Um, it was very good, Alan. We have no questions. Everybody got everything. So
Great.
um, I'm just gonna quickly introduce what we're gonna do for the next session. Give me a second. Okay. So save the date for the next session. That's on the 20th of October, the same time, whichever time zone you are, it'll be at the same time. So for Singapore, it's 3 p.m. And now that the last couple of sessions we've spoken a lot about the different capabilities of the software, in the next session we'd like to focus about how to set up your company or project BIM standards in Open Buildings Designer. We will introduce libraries, templates, and components to drive the project standards and improve the data quality management and improve the quality of deliverables in general, especially if you're working on a large project which has many contractors and designers involved. That's super helpful. And we will post the link to the next event soon. And that's all for the next event. We will have Kashia again. She'll be hosting this session on the 20th of October. So do join us. And thank you. Thank you for attending our session. Thank you, Alan. Thank you, Kashia.
Thank you.
Thanks. Bye. Bye.
Bye bye.